Zero-knowledge proofs, or ZK for short, represent one of the most powerful cryptographic innovations of the last decade. They allow someone to prove that a certain statement is true without revealing any information beyond the validity of the statement itself. Imagine being able to prove you know the password to a vault without ever saying the password. Or proving you're eligible to vote without revealing your identity, age, or location. That's the power of ZK. At its core, a zero-knowledge proof involves two parties, the prover and the verifier. The prover convinces the verifier that they possess knowledge, without revealing the actual knowledge. This is achieved through complex mathematical constructions, like ZK snarks or ZK starks, which create extremely compact cryptographic proofs. Now, when most people hear about ZK, they think about privacy in cryptocurrencies, but there's a much bigger frontier: zero-knowledge databases. Traditional databases require trust. When you query data, you're trusting that the backend is returning accurate results. But what if the data has been tampered with? What if the system itself is compromised? Even more critically, what if you're dealing with data that's too sensitive to reveal in the first place? That's where ZK databases come in. A zero-knowledge database allows you to verify that the result of a query is correct without ever seeing the underlying data. Think about this: a decentralized application needs to verify whether a user meets certain conditions, like holding a specific amount of tokens or fulfilling a KYC requirement, but it cannot access the user's personal data. A ZK database can prove the condition is satisfied, without exposing any private information. Or consider a machine learning model trained on proprietary or sensitive datasets. Instead of exposing the training data or the internal workings of the model, a ZK database can prove that a prediction was generated by a properly trained model, using valid inputs. ZK databases merge the speed and flexibility of NoSQL databases, like document storage, graph-based queries, or key-value stores, with cryptographic integrity. You don't have to trust the database anymore. Every data sample, every transformation, every query, all can be paired with a proof that it's correct and untampered. The way this works is modular. Data gets committed to the system using a Merkle-DAG structure, which allows for efficient and immutable storage. Then, when a user queries a value, the system generates a cryptographic proof, often using recursive zero-knowledge techniques, that the query result is consistent with the committed data. More advanced systems go even further. They allow for verifiable transformations of data, meaning not only is the data correct, but every function or calculation performed on that data is also provably correct, all without exposing the raw information. This kind of technology unlocks powerful use cases. In healthcare, you can verify patient eligibility for treatments or benefits without revealing medical records. In finance, auditors can verify compliance without accessing internal documents. In supply chains, you can prove product authenticity and origin without leaking business secrets. Even in AI, you can provide tamper-proof training data lineage for models used in high-stakes applications. And what's especially exciting is that this is no longer theoretical. For the first time, there's a live implementation of this entire stack, from data input to ZK verification, running in a way that anyone can participate in. No special hardware required. You don't need a high-end GPU or a custom validator node. You can run it straight from your browser, using your CPU. Whether you're on a gaming PC or a basic laptop, your device can contribute to the network by verifying small chunks of data, and earn tokens proportionally based on how much proof work you contribute. It's not mining in the traditional sense. It's not staking. It's proof generation. You're proving that data flows are valid and untampered, and you're getting rewarded for every valid proof you produce. There's one particular project pioneering this exact vision, making ZK databases accessible to the masses. But I'll let you explore that yourself. Just check the description if you're curious. Because what matters here isn't just the name of the project. It's the breakthrough itself. Zero-knowledge databases are real, they live, and they're redefining what we thought was possible in decentralized data integrity.